Okay, so this is how I can go back and forth between logarithms and exponentials. We are going to rewrite these first few here. They're currently in logarithmic form. We're going to rewrite it in exponential form. The thing? What's the thing we're talking about? What about big ideas?
The log and then the small 2.
Oh, the base? Yes. So on big ideas, I think you just type in log, just type in log. And then there's a little, I think it looks like a little box. So you can put like this little subscript, like a base. Okay. All right, so for this log base 2 of 16, yeah, nice, Jess, you totally got it. The base was a base of 2, so that should be the base on my exponent. And the exponent that I circled in purple here, that was what was on the other side of the equation of my logarithm, which on the other side of the equation was a 4 in this case. So I had 2 to the power of 4 equals, and then this was a y, which was the argument on my logarithm. It's supposed to equal the argument. The argument in this case was a 16. So 2 to the 4th equals 16. Now, is that true? If you did 2 to the 4th in the calculator, does it give you a 16?
Yeah.
It did? Yeah, you got it? Okay. That's a good sign here. 2 to the 4th equals 16. I rewrote my logarithmic equation in exponential form. All right, so let's try this again. The base of my logarithm needs to be the base of my exponent. So a base raised to, now the whole point of a logarithm is to solve for the exponent, whatever it was equal to. In this case, it was equal to 0. That should be my exponent. So it's like 4 raised to 0 equals the argument. This one was a 1 for my argument. So that equals 1, which is true. Anything to the power of 0 is 1. So there's my exponential form. All right, so let's see if you guys are getting it. For number 3, so I'm going to reach out to, let's see, I'm going to start with Tabitha here. Tabitha, what is the base on number 3? Nice. That base of my logarithm is like a little smaller, a little lower, that little subscript of 12. Good. And then, so Tabitha, keep it going. What's the exponent now? Nice. Whatever this was equal to is equal to the 1. So my exponent was 1. All right. And then in exponential form, what is my 12 to the 1 equal to? Very good. The argument was another 12. So 12 to the first equals 12, which kind of makes sense. That's true. 12 raised to the power of 1 equals 12. All right, let's try. We got last one here. In this section at least. What is, let's see, I'm going to reach out to Bailey. Bailey, what's the base on this logarithm? Nice, 1/4. And then what should my exponent be now? -1, nice. Okay, so I am gonna have to put the entire 1/4, I'm gonna put some parentheses around it. The entire 1/4 fraction is all raised to the -1. All right, and then what does this equal? Nice, a +4, which is true. Are you guys familiar with negative exponents? Yeah, what do negative exponents do?
I'm familiar with them, but I don't
Familiar
know
with
what they do.
Okay, let's brush up on that real quick. Why is 1/4 raised to a -1? Why does that equal a nice pretty whole number? It gave me a +4 there. Let's see, Landon, can you describe to me what negative exponents do? Landon, are you there, hon? All right, well, I'm going to reach out to Abigail then. Abigail, can you describe what a negative exponent does?
I don't know.
Not entirely sure. All right, so Sally, can you explain it to us, and then Abigail will come back to you?
Negative exponent?
Yeah, what do negative exponents do?
It means it's the same as it over one.
Over one, so like it flips your fraction, it's a reciprocal?
Yeah.
Nice, okay, so it's the reciprocal. It kind of goes from my 1/4 over to, this is like a 4 over 1. Does that make any sense? Went from a 1/4 to a 4 over 1, and it was raised to a positive 1 now. So if I had like, okay, so Abigail, I'm going to come back to you. If I had like 2/5, let's do that to a negative 1. So Abigail, what's the reciprocal of 2/5?
Would it be 5 over 2?
Totally, 5 over 2. And then what's my exponent now?
Would it just be a 1?
Yeah, totally. You kind of took care of the negative already. You flipped the fraction to the reciprocal. You kind of already took care of the negative. So this is like to a positive 1, which really, do I need to raise anything to a power of 1? Not really. It doesn't do anything. So I would just leave it as the 5/2. And that's kind of what we were doing right here with the 1/4. 1/4 to a negative 1 is a 4 over 1, or just 4. All right. Okay, so lots of your exponent rules are going to come up in these logarithmic equations. So we are going to do number 5 here. We are going to go backwards, going from exponential into logarithms now. All right, so I need to do a log with a base. And in this case, it looks like the base on my exponential was a 5, so I should have a log base 5. Again, put it as like a little subscript, like it's smaller, a little lower. And then the arguments. That should be what was on the other side of the equal sign. This was a 25. It's like log base 5 of 25. And did you guys notice that I kind of put these are on the same line? The log and the 25 are on the same line. It's the base, that 5 is that lower, smaller number there. And this should, again, the whole point of this is to equal the exponent. My exponent in this case was a positive 2, so this will equal 2.
Well, I didn't get anyone near that.
That's all right.
How would you put in the base for the log? I can't quite remember.
Like, how do you type it in, or?
Yeah.
So I think on your homework, it'll have like a button you can push for like a little subscript. So I think you have to type LOG, you have to type log, but then you can put, it's in the calculator section. I think you can push this button to add a base. All right, and then, oh, Jess, does that help you out for your homework? Like how to find that symbol for your subscript? I think on your big ideas, it looks something either like something like this or a line with a little, but if you're looking for a little subscript is like smaller, a little lower, and then you can enter it in. Okay, so Evan's got an X. It's like this, like X. Okay. So Jess, you were looking for the one on big ideas, or you were looking for the one where? Oh, like if you just type it here in the. Yeah, so that's pretty hard to do here. I would just type like, yeah, that for exponents. If you were just typing it though, for me, I would know what you were talking about if you went like this. It's not technically correct. That 5 should be a subscript, but if you put the 25 in parentheses, I know that you're separating the 25. I would know that your 25 is the argument and the 5 is the base. Does that make any sense? All right, cool. Okay, so then let's do this number 6 here. We're going to turn it into a logarithmic form. It's got a log with a base and an argument, and it should equal, wait, Maya, what does it equal every time? The exponent. Nice. This exponent was a -1. Okay, so here's where I see the mistakes. Usually people put the -1 right there. It's this whole like base and argument that people tend to mix up. So the base on my exponential, whatever is raised to the power, that should be the base on my logarithm. And I have to have this argument. I have to have the 0.1 in my logarithm. So this is what I see people do. I see people go log base 10 equals -1. First of all, they're missing that 0.1. It should be there somewhere. But it has to go right here in the argument. Like, okay, if you guys said square root like equals 4, does that even make sense? Like, if I said square root equals 4, would you guys know what I was talking about? Oh, come on, people. What's the problem? What's it missing? Something in your square root. You have to do the square root of something. Square root of 16 is 4. Square root, yeah. Square root of x even. Like, you got to have the square root of something. Same for my logarithm. I got to have log base 10 of something. I'm missing the argument. So this is what I see more than anything. People tend to ignore the argument. You need both the base and the argument in order to have it in correct format. All right, so here's that one. All right, looks like you guys online are working together really well. I like it. Yeah, which question?
How do you like put it in your calculator, the bottom,
The base?
exponent?
Oh, so we're actually going to talk about that in a sec here. There are 2 specific logarithms you can probably do in your calculator, but you probably can't enter whatever log you want, whatever base you want, really. You can probably do a log base 10 or a natural log, like a log base E. But those are probably the only 2 bases you can use. If it's a scientific calculator especially, those are probably the only ones you can use. So we'll deal with that in a bit. Okay, good question. So I'm going to rewrite this one right here. All right, so let's see. Crystal, what is the base on this number 7 here? Like, what should I underline in blue? The 8, nice. The 8 is the base. So I'll put a log base 8. And then the argument that I usually put in green, what should be my argument?
4.
Totally, 4, very good. And this equals, what should this equal? Two-thirds, totally. This, every time, it'll equal the exponent. So this was an exponent of 2/3, very good. All right. All right, so number 8, last one here. So Wilson, are you there, hon? No response from Wilson. What about Lauren? Lauren, are you there? Nice, Lauren. Okay, so Lauren, I'm going to have you help me write this in logarithmic form. What is the base on number 8 here? Okay, I will need that, but not necessarily as the base. So the base is what I've had in blue. The base is what is then raised to the exponent. So on this particular problem, what is the base that is raised to an exponent? Oh, you're good. So yeah, the 6, you got it. 6 is the base. So then your 1/126, that's actually the argument. And I'm going to put some parentheses around it. Like I need the entire fraction. Careful on your calculators, you guys. Make sure you put, again, if it's a fraction, I want to put it in parentheses. just to be safe here. And then this equals, let's see, what am I equal to now, Lauren? Nice, -3, your exponent was a -3. Very good, okay. So we have basically gone back and forth from exponentials to logarithms and logarithms to exponentials. Any questions on these guys before we move on? Yeah.
What would you do if, for the bottom row, what would you do if there was like a zero, exponent?
Oh, nice, okay, so pick another number.
12?
12, so if I had 12 to the 0, what is 12 to the 0 anyway? 12 to the power of 1 is 12. 12 raised to the 0 is 1. That's kind of our exponent rule, which we're actually about to talk about that. That's kind of what I see right here. A base raised to a power of 0 is 1. But exponential turned into logarithmic form, I would have a log base 12 of 1 equals 0. So your exponent could be a 0. That's fine. Is that what you were talking about? Uh-huh. All right, so that actually leads into this really well. This was it like a straight up homework problem that you just asked?
Yeah.
Yeah, I turd. All right. These log rules, they have to do it. So they're called log rules, but it has to do with your exponent rules. Like I was just saying how your exponent rule was any base to a power of 0 is 1. Another exponent rule is some base raised to the power of 1 is itself. And if I turn those into logarithmic form, your logarithmic form always solves for the exponent. So this one is saying log base b of 1 equals the exponent equals 0. Or this guy right here, log base b of b, if these guys match, if the base and the argument match, it's going to equal an exponent of 1. Okay, so let's see if we can apply that here. All right, we're going to do log base 4 of. All right, so Samantha, I've got a log base 4, and I want it to match. I want to have the base and the argument match. I don't see them matching as of right now. So let's just try to rewrite this. If I put this equals x, how can I write it as an exponential format?
So are they supposed to, like, above where it's like, you were trying to see if they match someone? Is that what you're talking
They might match. So we got these rules because we might use them. We're not guaranteed to have to use those rules though.
Okay, but you just want them to equal the same thing?
Yeah, if I was going to use these rules, I would want them to equal the same thing. As of right now, it looks like I have a log base 4 and then a 64. They don't look like the exact same thing. So maybe let's try to look at it in exponential form. So you know how up here we were going from the log form into the exponential form?
Yeah.
So let's see if we can rewrite this one in exponential form. Maybe we know how to answer that. Let's check it out. So what's the base? The base, okay, is the 4. Raised to what exponent? So not raised to the 64. The 64 is actually going to be what this all equals.
Yeah. It would be x or it would be nothing.
It would be the x, yeah, nice. So the logarithm should always equal your exponent. So in our case, the exponent was x. All right, so do you know what 4 raised to what exponent can be that gives you a 64? 3. Okay, 4 to the 3rd is 64. Nice, so my x is 3. Very good. All right, so then let's see here. Thomas, are you there? I think you're online today. Nice, okay. So Thomas, let's rewrite this one. Oh yeah, I always forget we have 2 Thomases, sorry. I'm looking at Thomas W. Nice, there you go. So Thomas Wiseman, there we go. I'm gonna make this equal an x again. So can you help me write this in exponential format? What's the base? Let's start with that. What's the base? Nice, 5 raised to, what's the exponent? Very good. Your logarithms are always equal to whatever the exponent was. So 5 to the x equals, what does this equal now? 0.2. Very good. Which, do you know what exponent you can put on your 5 and get a 0.2? What if we look at it this way? Can I put 0.2 as a fraction? Does anybody know what fraction I can do for this?
1/5.
Oh, 1/5? Okay, so now Thomas, now if it's a 1/5, let's think about it this way. 5 to what exponent is 1/5? So Thomas, I'm sticking with you here.
What was the question?
Yeah, 5 to what exponent? And you got a -1. That's true. 5 to a -1 is 1/5. That's kind of what we were talking about up here. Let's see. We did a 4 to the negative, or sorry, 1/4 to the -1 was a 4. Like basically did the reciprocal of your fraction. Same deal here. Nice. If my x is a -1, 5 to the -1 is 1/5. Very good. All right, so let's keep it going here.
Miss Jane,
So the base on this one, yeah.
are you just guessing the, not the numerators, holy heck, the numbers to see what
The
they,
exponents?
yeah.
So
Or
I'm
how-
not really guessing necessarily. I'm using the rules that I know. Like this one that we were just doing, I was kind of using what I know about negative exponents does the reciprocal. So because I could tell that 5 and 1/5 are the reciprocal, that kind of made me go toward the negative exponent and then -1 for sure.
Okay.
So I kind of been using my exponent rules to help me identify what it is. This one right here, I'm going to do my base of 1/5 raised to the x. And again, I put parentheses around it. The entire 1/5 raised to the x has to be a 25. Okay, so I'm going to, there's a hint in this one. So this is kind of, I think, Laura, this is kind of what you were talking about. I'm not going to guess it, but I do know to go from this fraction of 1/5 to a nice pretty whole number, I'm going to have to do the reciprocal. I'm going to have some negative exponent. So I know my x is a negative something. If it was -1 though, I would get like 5 to the first. Yeah.
Would it be like -2?
-2 would be 5 over 1 and then squared. So it does the reciprocal. Instead of 1 over 5, it goes 5 over 1 and then squared, which is 25. Yeah, totally. Looks good. And then last one right here, again, I'm going to treat it like it's equal to x. 36 to what exponent is a 6? This one can be a little tricky just because I know it's getting smaller, but it didn't turn into a fraction, right? So like if I put a -1, 36 to the -1, that's this fraction. I don't want it like that. So I don't think the negatives are going to be all that helpful here. Any ideas on 36 to what exponent can be 6? Yeah. 1/2. How'd you get that? You kind of did a guessing game. Okay, that's true. It is a 1/2, but here's why. In my head, here's how I thought of it. Isn't the square root of 36, that's 6, right? Square root of 36. And a square root, we have in the past treated it as a 1/2 exponent. So 36 to the 1/2 is taking the square root of 36, and that is a 6. My x is 1/2. So I didn't necessarily need a negative. I needed this fraction, 1/2. If I needed to do like the cube root, I would have to have a 1/3 exponent. If I needed a 4th root, a 1/4 exponent, and so on. Yes.
I actually looking over the homework while doing it.
Uh-huh.
So while watching you do this, I can't figure out what log to the base of 1/2 and then 1 is equal. I've been trying to like follow you along like replace the number you're using it to.
Uh-huh.
And I can't figure it out.
So you had a log with some base of 1, right?
Log with 1/2 base is 1.
You had something like that?
Yeah.
Okay, well, first of all, I think this log rules are going to be very helpful. So we're actually, let's look at this one right here. Natural log of 1. It's like log base e, but of 1. And if the argument is a 1, I'm going to use this rule. I don't even care what the base is. If my argument is 1, it all equals 0. So log base 1/2 of 1, I could have log base like 5.278 of 1. As messy as that is, I don't care what the base is. If the argument is a 1, this is going to end up equaling 0.
Okay.
Yeah.
And what was the log base of 3 to the argument of 3?
This rule right here, log base 3 of 3 is my log base b of b. What does it equal?
1.
There you go. Equals 1. Quit having me do your homework. You do your homework.
Well, I was trying to figure out how to do it while watching you do the other stuff.
Yeah, we're gonna, so that's about these rules. We're about to use those rules right here, actually. So these ones down here, you've got some common logarithm and a natural logarithm. These are gonna be the ones you can see on your calculator, actually. So I think you guys look at your calculator. Do you see one that looks like this? It doesn't even have a base on it. Do you guys see one of those?
Yeah.
Yeah. Okay, so that's kind of like, you know, my square root versus my cube root and my 4th root and my 5th root. Like if I didn't put a 2 right here, we're just going to assume it's a square root, right? Same thing with my logarithms. If I don't write a base, we're just going to assume it is a log base 10. It's like the most, it's called a common logarithm, most common. So if they don't write a base, we're going to assume it's a log base 10. This one is a natural log. You probably also have a natural log button on your calculator, which is a log base e. We did a bunch of work with e yesterday. It's a constant term. You don't get to choose what the e is. It's not a variable. If you have a log base e, they're going to call it natural log, which why don't they write NL? I don't know. But ln is your natural log. It's a log base e. So you guys probably have an ln button, natural log button on your calculator. All right, so this one says evaluate each logarithm using a calculator and round to the nearest thousandth or 3 decimal places. So bust out whatever calculator you're going to use on your homework or your test. Let's get familiar with it. So for me, I've got my log button over here on the left, and they didn't write a base because it's log base 10. So I've got this log button, and I'm doing log of 8. I think in the scientific calculators, it's usually, I think, up at the top on your scientific calculators. Let's check that out. I did log of 8. Let's see if we all got the same decimal. I got a 0.9030899, yada, yada. You guys at home, put this in your calculator. Will you let me know if you got the same thing? Everybody at home, let me know. Did you get the same thing? All right, thanks, Laura. Nice, Lonnie, Bailey. All right, Tabitha, Jack. Nice, you guys, check it out in your calculator. I want to make sure that we know how to use our calculator. Honestly, if I had you guys in the class, I'd walk around and make sure that we knew how to put this in, but I can't walk around right now, so I want you guys to tell me if you put it in correctly. All right. You guys in here? Let me see, thumbs up, thumbs down. Did I get the same thing or not? A few thumbs up. Up front here, we're still missing a few. Siler, Crystal. Yeah. It will automatically use a base of 10. If it does not write the base, it's automatically a base 10. Yep. Okay, so I'm going to go to the nearest thousandth, so 3 decimal places. I'm going to go with 0.903. All right, and then you also, I believe, have an ln, a natural log button. So find that one. For me, it's on the left side here. Again, I think scientific calculators is usually near the top. So check that out. I'm going to do my natural log, my ln, of 0.3. All right. So I want to make sure you guys got the same answer again. Let me know. You guys at home? Did you guys get the same thing? I got a negative 1.20397, yada, yada. Let me see if you guys got the same thing. In the classroom, let me see. Hands up. Did you get, or thumbs up? Did you get it or did you not? last part, okay. So Laura, for me, it was on the left side here. It was right under where it said log. All right, you got the same thing? How are we doing, Evan? Did you find the LN button?
The what?
LN, natural log button?
I have the log button, but LN.
All right, you got it?
I'll find it in a second.
Okay, so I'm gonna go to the nearest 1,003 decimals. That 9 is gonna make
Okay,
me round
found
up to, you did?
Yep.
Okay, so negative 1.204 in this case. All right, so let's give this a shot here. So Aaron, are you there, hon? Nice, Aaron. So will you put this one in your calculator, and then I'll have Jacob, I think you're at home today. Jacob, will you put natural log 1 in your calculator? Nice. Okay, so Jacob, you already put yours in. You got a 0, straight up 0.
0.
That's what you got as well? Nice, which actually, so we're going to go back to our rule up here. This was a natural log of 1 that we just put in, right? It's like a log base e of 1. So it fits this rule. It was supposed to equal 0. Nice, so that was one of our logarithm rules. And then Aaron, you got a 1 on this one, which that actually fits one of our log rules as well. They didn't write the base of 10, but it is a log base 10 of 10. So the base and the argument are the same, which is this rule up here. The base and the argument are the same, so it ended up equaling just a 1. So that was those log rules we had. You probably didn't have to use a calculator for it if you know those log rules. Okay, questions on this before we move on? All right. All right, so let's look at these ones. These are inverse properties. Inverse, let's talk about inverse for a sec here. Like what is, I'm just gonna call on some people here. Laura, what's the inverse of addition?
Subtraction.
Totally, subtraction. I know it seems like a dumb question, but I mean, we need to look at this. Alani, what is the inverse of multiplication? Nice, division. Those are inverses. What about this one? Sadie, what is the inverse of like a square root? Is Sadie there? All right, not hearing from Sadie. So I'm going to come to you, Jess. Jess, what's the inverse of a square root? Squaring something? Okay, so like a squared exponent, like square root of x, x squared. Nice. Okay, those are inverses. So they totally undo each other, right? If I add and subtract the same thing, I usually like cross them out. That's a lot of times we say cancel. Same thing here with our exponential and logarithms that have the same base. They have to have the same base. Not any logarithm can get rid of, you know, any exponential type format. It has to be the same base on both of them. So this is b raised to, so this is an exponential, b raised to an exponent. And then I've got a log base b. So those kind of undo each other. All I have left is the argument x. And same thing if it was the other way around. If I had a log base b of, and then here's my exponential with the base of b, those again would undo each other. They're inverses. All I have left is the x either way. Okay, so we are going to apply that to these expressions down here. And for some reason, I think this has online, it has a 4. For some reason, it didn't print there. So I don't know if you guys need to write this down or what. This should be 10 raised to log of 4. All right. So, hey, Wilson, I'm going to come your way. Wilson, if I didn't write a base, what is the base on this one? Nice. Yeah, totally. This is a base 10. So I actually do have the same base on my exponent. I have the same base on my logarithm. So those actually are inverses. All I'm left with is the 4. They didn't even have to write the base. It was a base 10. Nice. All right. So then, Lauren, I'm going to come your way then. Currently, these bases do not match. I want to have a log base 5 with 5 to some exponent, right? I want my bases to match. So Lauren, what can I do for this 25? How can I adjust it? All right, Bailey, I will in just a sec. So Lauren, I'm trying to figure out what could I put as an exponent on a 5 to make it equal to what I started with. Okay, I think you're close. I think you're talking about 5 times 5 is 25. That's true. But I need an exponent. So it's like 5 raised to what exponent? Squared. Okay, so it's like raised to the power of 2. Nice. 5 squared is 25. And they had 25 raised to the x. It's like my 5 squared is to the x. All right, so we did this yesterday. We did exponent rules. I don't know if you guys remember these, but if I have an exponent raised to another exponent, I have to multiply those exponents. So I'm going to do 2 times x, so 2x. I multiplied my exponents. And my goal was to have a log with whatever base and my exponential with the same base. And I do now. I have a log base 5 and I have an exponential with a base of 5. Without the parentheses or anything. Nice. So those are gone. All I'm left with is the exponent. So 2x is my final answer. All right. And then Bailey, what kind of question do you have for number 17? Maya, I'll come your way in a sec. Okay. So how we got this was, I was looking at kind of this rule right here, where I have the base on my exponential matches the base on the logarithm that's in the exponent. Like, so this one has a base of 10 raised to, this is a log base 10. They didn't write it, but if that's like your common log up here, if they don't write what the base is, it's because it's a base 10. So because I had an exponential with a base of 10 and my logarithm with a base of 10, they undid each other and all I had left was the argument, the 4. So Bailey, does that clarify at all? Okay, cool. And then Maya, what was your question? So that's again for this reason over here. You've got a log with a base of b and an exponential with a base of b. It's like we were talking about up here, how like a square root and squared exponent, they totally undo each other. Multiplication and division, those are inverses, they totally undo each other. Same deal here. I've got a log base b and exponential base b. So those are gone. All I'm left with is the exponent, in this case an x. Is that a little better? Awesome. Okay. I did want to see a single exponent though. I didn't want to see like over here when I had an exponent raised to another exponent. I wanted a single exponent. That's why we got the 2x. All right. And then let's look at number 19 here. All right. So I've got a log base 7. My exponential has a base of 7. So they actually already have the same base. I actually can be done with those and just have a negative 3x for my final answer. All right, and then number 20, last one for today, you guys. Evan, what's the base on a natural log? Yeah.
Are you asking for a specific number?
No, just on any natural log, that type of
Isn't that
logarithm.
10 or-
Oh, my common log is a base 10, yes.
oh, okay.
My natural log is a base of, here, I'll move this up a little bit. My natural log is base E, yes. Which the good thing is I've got an exponential with a base of E and I have a logarithm with a base of E. So bam, gone, nice Jacob. So this is a 0.9 is all I have left. Okay, do you guys have any questions on this stuff? No, we're good. Let me know what questions you have.